Hold tight to that for just a moment. Just a moment. So, friends, thank you. This is beautiful. Thank you for this. What's fun about this, and it answers Linda's question from before, will you be able to recognize symmetric data from a box plot? The answer is yes. Teresa, yours came back almost exactly bell-shaped. Can you identify which of those box plots represents the most symmetric data? Remember the median. Remember the median is the line. These are the medians. Those are the medians. So imagine. Now I know I see a bunch of you going like this, and this is good. Usually I put box plots front them this way, but it looked like crap having them run that way with this many of them, so I stacked them vertically. So the inches are actually here. So can you find the most symmetric? Yeah, it's not perfectly symmetric. It's damn close to perfect. Kevin, you see it?
12.
12! Look at group 12. The whiskers are almost exactly the same length. The median's off, yeah? It's not perfect, but it's damn close. I think it's more symmetric than, say, the one next to it, where you've got a little tiny whisker here and then a big long whisker here. There's quite a bit of asymmetry. It's very hard to pull a symmetric sample from this data because the data itself is pretty asymmetric. I want to get back into that. I want to talk about that more momentarily.
Yeah, all this data looks like the picture.
Yeah, yes, exactly. Now, you might think it's silly. You're like, well, Rule, dude, you gave us 1927 to 2013. Why didn't we just input all those years in and just analyze the whole thing? It's a great question. Was anybody thinking that? No, you would think, why the hell would you do that? That's 5 times too much work.
Right, this was divide and conquer.
It is divide and conquer. Very good, very good. And more so than you even realize. Hold that thought, too. The idea is that, in general, you don't have your population. You pull a sample from your population, right? In here, it's a blessing because we actually do have the population of snowfall recorded data, and we can draw a sample and see how we do. That's what the trick is. How did we do with these individual samples? So let's look, overriding. Now, first of all, put your minds at ease. You're all getting 10s on this quiz because you all wrote your 5-number summaries down, right?
Yep.
That was level 1 of the quiz, was making sure you could pull the 5-number summaries down. Honestly, that was level 1. If you did level 1, that's worth 10 points. Everything else is just the icing. So look, these box plots do vary quite a bit, yes?
Yep.
Yeah.
But are they also consistent in any way? I'm asking a bit of a 243.5 question here, or a 244 question. Andrea?
The median's
The one
close.
up that way is longer than the one on the left.
A consistency amongst the box plots. Teresa, yours was definitely the exception of this rule. But the high whisker, was definitely longer in general than the low whisker. That means use the increment 25% and talk about the 25%. Because this whisker does represent 25% of something, doesn't it?
Right, the Q.
Generally more distance between the data on that side of, can't get it out.
That's okay, you're saying the right thing. There's more variation in the high snowfall years than in the low snowfall years. And I'm breaking it down by quarters, of course. I'm arbitrarily breaking these into quarters. The low 25%, the next 25, the next 25, and the largest 25%. There's more variation up there. Good for you. Well said. Well said. Notice, here's the other class's data. Does it hold true for them as well?
Yeah.
It holds true for them as well. And interestingly enough, group 12 is almost as symmetric as our group. That's kind of crazy, actually. Freaky. Cool? Good, good. Excellent. Thank you. Candace and Andrea, how else are the graphs similar? Or what other commonalities do the graphs hold? What else do you notice? There's definitely noise in the sampling, and I love the fact. If these box plots all came out the same, I mean, like these two here are pretty close, yeah? If I had 12, that would look almost the same. I'm watching you guys more carefully. But they don't. But there is like an underlying commonality. What else is common? Say that again, Linda.
The median's right.
Look at the median. Follow the median. There's definitely a bit of a, not a pattern, but a hovering around a certain value. When you come across, it's right about in here, which is where the Bend Chamber of Commerce tells us the average snowfall is every year.
Yeah.
Ha ha! They don't mention a plus or minus. Of course they don't. They're Americans. But still, they're getting pretty close to where. Now, there are certain ones that fell down pretty far. But look at the hovering, right? The hovering around that. Please, Candace. Thank you, Linda.
There's a
Beautiful.
trend in the minimum too, which might be part of why, because they gave us all those zeros or whatever.
Because the minimums are very consistent. Even more, one would argue maybe even more consistent, huh? And again, remember what you said, I think it was you, Candace, or Andrea, one of you two guys said, there's less variation in the low years than the low snow years and the high snow years. Since there's less variation, there's more clustering in the low snow years, which means the minimum should be coming out repeatedly. Let's see if it works with other classes as well. Did it work for their data as well?
Yep.
Hot damn it did! Look at the medians. Their medians are even more like that. Except for, popped up. But then again, in Math 244, we often mention what's called a 95% confidence interval. That means, and we've talked about it here briefly from time to time, 95% of the time we do sample surveys, we catch what we're looking for with the net that we've thrown. That means we miss it 5% of the time. We're going to miss it 1 in 20 times. That could very well be 1 in 20. Good, good. So the medians look very similar. The minimums, the quartiles are a little bit noisy, aren't they? Quartiles are a bit, the boxes range. But I love the comparison between the low and the high and the middles. Very, very good. Now, this is the takeaway. This is like a level 4, level 5 takeaway. What I did here, make sure you guys can see it. Hold it up. Okay. So, this is a box plot created from the entire data set, which means I took 1927 up to 2013 and I plotted it all right here. The snowfall's right here. This is a combination of all of your guys' sample data collected together and dropped into one plot. What do you notice?
Pretty close.
Very similar.
Give me goosebumps every time I say it. You guys, on average, target the population. Why does it give me goosebumps? Why do I get all happy? Why do I get all happy?
Sample works really well.
Because that means your sample's working! Tom, go!
Why is that teaching this class for a while?
Well, because what are you learning that you can take into the world with you?
How to do that?
Yeah, because you can draw a sample, view your data, and get something meaningful from it. Go, sir.
Does the size of the box mean anything in relation to each other?
What does the size? Thank you.
Sure.
What does the size of the box mean? Let's go back to your individual sample data. What does this tell you? Now, it's varies.
I mean, but these are all the same width, right?
Oh, with this way.
Yeah.
Oh no, I see what you're saying.
I guess
No,
like total.
that's just a total Excel thing.
total square area, like.
Nope.
big.
There.
Okay.
Yeah, not at
So it
all.
doesn't
That was
matter.
just me drawing it out to cover data. No, sir, not at all. But the question I thought you asked is worth answering. Honestly.
Sure. No, I.
What does it mean, Linda?
Isn't the bottom of the box the Q1?
Yes.
The top Q3?
Yes. So therefore, how much of your data is in the box?
50%.
Half of it. The middle 50. So remember how before, with bell-shaped data, we had the 68, the 95, the 99, and so forth, those guidelines for percentages within. And then you think, oh crap, now we have skewed data, we really can't do that anymore. But you're not completely out to lunch. You can still draw a box plot and say, the middle half of my data is between this value and this value. So this is another useful tool to keep. The square area though, Tom, is completely arbitrary with how I made the graph, yeah. But the box itself though, does show you where half of your data lies. The extreme bottom, or the extreme top, the extreme bottom, and the middle 50. Is that fair?
Yep.
Believable? Hopefully, maybe good. One last thing. How many of you guys were able to do like the 17 and the 18 on to get the outliers? Some of you did, some of you didn't. So Mason, you're like, I didn't get it. Good, good. What I want to do is I want to try to ballpark, I want to try to eyeball as I go through the data sets. You guys know which ones yours were up here, right?
Yep.
Yeah.
I don't know who was who. But I'm going to try to look at here and see if I can figure out which of your data sets had outliers and which ones didn't. That make sense? So group 1, I don't think you did. Group 2, I do think you did. Group 3 did not. Group 4 did not. Group 5, that's a tough one. I don't think it did. Group 6 did not. Group 7 did not. Group 8 is as tough as Group 6. I'm going to say it did. Group 9, whew, these are also damn close. I'm going to skip group, no, what the hell? No, yes, yes, no. How did I do? Did I do okay? Okay, I probably missed 1 or 2 because I was ballparking it.
You got ours right.
I got yours right. Okay, your TI, what your TI was doing was a little teeny tiny bit of geometry. It does this with its fingers. Tom, back to your box. It takes the box. It calls that a unit. It's actually called the interquartile range. Don't remember that right now. We'll come back to it on Thursday. It takes that distance, increases it by 50%, and then it stacks that on Q3 and Q1. I don't know why it's 1.5. I just know it is. That's the number that's been used. If you put those fences up and one of the whiskers pops out of the fence, that means you have at least one outlier. It made it out of that fence of reasonability. When I was asking earlier, if Max is 80th percentile, is that too big? Essentially, that too big, that gut feeling you have, this is one way statisticians metric outliers. They take that box, increase it by 50%, and then stack. If anything gets outside of that range, that's said to be too big. Is this gospel? Hell no, it's just used. It's just what we use. So this one here, 50%. Aha! You guys had one, didn't you, group 2?
Yeah.
Yes! Group 3! Oh no. I'm not gonna bother checking the low end, right? Because there aren't any low end. Group 4? Group 5? That was damn close. Was I wrong on group 5? I can't remember. Who's group 5? They've left. They got tired. Group 6, I think, is in the clear. Group 7, I think, is in the clear.
Oh, you go from the median.
You go from the quartiles. You measure the box, which includes the median, increase it by 50%, and then stack it on the quartiles. The median actually isn't part of the computation of this.
Are you going to talk about that more?
Oh, Thursday! Oh God, this is just a bridge for Thursday. Oh, sweet Jesus, yes. Namaste, don't worry. Keep going. Oh, get to you guys. Sorry. Hey, don't stop.
Yes.
Oh, you guys had one?
Yep. they have
Yes. Oh yeah, you guys had
Yes.
one. Ooh,
one. That's close, but
it's
yes.
close, but I think you did. Oh, you guys did.
No.
No.
Yeah. It's almost close on this side too, which is fun with that one. I've never seen one like that symmetry. Fun. Cool?
Yeah.
Got the glimpse at Thursday, which is how to metric these damn outliers, these unusual data points. Cool? All right, we'll get to them then. Stack of quizzes, yes. Let's put those, how about right here?
One per group.
One per group with all your names on it is fine, yes. Just so I know who to give credit to, which is all of them. Have fun with the exam. I know you are.
Yeah.
And when I say fun, well...